All right, fine. So let's have a look at the first one. So we need to integrate between 0 and 1 this particular quotient. So 5x cubed divided by x to the 4 plus 2, all raised to the power 5 with respect to x. Okay, don't worry about the limits. Tell me some techniques which you could employ to figure out how to do this. Yeah, good. I heard it. Integration by substitution. That's a good start, right? Have a look on the denominator. Look, with practice, you will start to recognize when one would be better than the other. But yeah, so here I can see on the denominator, you have that awkward thing. You have x to the 4 plus 2, and then that's all raised to another power, okay? So when you have like a function buried within another function, I recommend using integration by substitution, okay? Now you might say, well, what about the 5x cubed? Well, watch, it actually falls out quite nicely. So if I just say, let u be my x to the 4 plus 2, so in other words, the bit inside that bracket, right? I'm not going to worry about the limits, I'll do that at the end, right? I end up with the integral of 5x cubed. Well, now that whole thing becomes u to the power 5. Happy with that?
Yeah.
So u to the 5. However, I also need to make a substitution for this dx, okay? Well, I can get that by thinking about du by dx and then rearranging, okay? So if I differentiate this, I can say du by dx is equal to 4x cubed, right? Which means that dx, if I just do a little bit of rearranging, dx is equal to, that's going to be 1 over 4x cubed times by du. Does that make sense? Just simply rearranging this particular equation, multiply through by dx, divide by the 4x cubed. Yeah? Okay, so now if I put this back in over here on the right hand side, I end up with 1 divided by 4x cubed with respect to u. Yeah? And now this is the reason why I wasn't worried about that x cubed, because it actually gets cancelled. Okay, nice. So we cancelled those off. Let me just do a little bit of tidying up. I'm going to do 5 over 4, and because it's a constant, I'm going to pull it out the front of the integration. Okay? So I'm going to take the 5 over 4 out the front. I don't want that in the way of my integral. Remember, it's just a constant, so I can pull it out, make it look a bit tidier. And I'm going to write 1 over u to the power 5 as u to the negative 5. Okay? So that looks a little bit tidier, certainly than what we started with, but even tidier than this one still. All right, so what's the integral of u to the power of negative 5 with respect to u? What do I do for integration of powers?
You divide it by...
That's the topic we need you more.
Divided by n plus 1. That's
Okay, good.
to the power of n plus 1.
Okay, so let's just do it over on the right hand side just to remind ourselves. If I start with a function like this, okay, if I differentiate, it might be easier to think in terms of differentiation, okay, what are the 2 steps that I need to do? So first of all,
We take this and subtract 1.
perfect. So the first step is multiply by the power.
Yeah.
And the second step is reduce the power by 1 or subtract 1 from the power.
Are we going to do the same thing?
Almost. Exactly, we need to do the reverse thing. So that's basically if I wanted to differentiate. Okay, so that become an x to the power of n minus 1. Okay, when I'm integrating, remember that integration is the reverse of differentiation. So I guess I could just write very naughty notation, but it just kind of gets the idea across. Okay, so remembering that integration and differentiation are inverse of each other, it makes sense that if I'm differentiating, I move from here to here. If I'm integrating, I need to move from here back to here. Okay, of course there's a little bit of a difference, but we'll worry about that in a second. This subtracting 1 from the power, how do I undo it? So what's the first step of integration? What's the opposite of subtract 1?
Adding.
Good, add 1. So add 1 to the power. And then the second step, I need to undoing multiplying by the power. So what's the opposite? Perfect, so I need to divide by the power. Okay, so just keep this in the back of your minds, right? So your power rule for integration and differentiation is there in red on the right-hand side. Just think, if you understand differentiating, moving from here to here, that's kind of the one which we meet first, it's the kind of one which sticks in people's brains, then just write out the reverse of it, and then you'll get integration. So if we do that then, first things first, I need to add 1 to the power. So what's negative 5 plus 1? Minus 4, good, negative 4. Then I need to divide by that power. So if I divide by negative 4, I could just write that as 1 divided by negative 4 like that. Okay. Now obviously, just because I've done no limits for the time being, I will come back and put the limits in so it doesn't matter too much. But I'm going to put plus c. That's my constant of integration there. And in fact, I'm going to put my plus c right at the very end so it doesn't interact with any of my other constants and get confusing. Okay. That constant of integration has to be there because I don't have any initial conditions. I don't know what the value of u is when whatever my function is equal to. Now I can just tidy this up slightly. So I can say, okay, this is going to be negative 5/16 of 1 over u to the power 4, so that can be u to the power 4 plus c. So just using my powers, tidying it up slightly. And then finally, I can just go back and say, well, I didn't have u originally, I had x to the power 4 plus 2. This will be negative 5 over 16 x to the power 4 plus 2, all raised to the power 4, plus c.
Can you see?
So that will be my final integration, that will be my final integral. So given this particular quotient, when I integrate with respect to x, this is what it will be equal to. The only thing that I need to be aware of now is that I've got limits between 0 and 1. So I need to go back and substitute those limits in. So I'll just put brackets around here, go back and substitute my limits. Okay. Now just for the sake of space, I'll write it over here. So how do I go about substituting my limits into this area function, if you like, this integral? How do I substitute my limits in?
Well, you replace the x value with the top value, which is 1 in this case. And
Yep.
subtract with the other, which is 0.
Yeah, perfect.
Replacing the same.
So plug 1 in first, then plug 0, subtract them in that order. Okay, so let's give that a go. Negative 5 over 16 times by, now I'm going to do this in my head, 1 to the power 4 is still 1, plus 2, that's going to be 3, 3 to the power 4, 81. All right, so I've done that step in my head, just to make my life a little bit easier. Now I'm going to put that in a bracket because I've still got a negative going on. So then I'm going to subtract the same thing, but with 0 stuck in here. So it's going to be negative 5 divided by 16 times by, if I stick 0 in here, let's do that in our heads. 0 to the power 4 is still 0. Plus 2, that's 2. Raised to the power 4, that is almost
16.
16.
16.
Yep. That makes our lives a little bit easier when it comes to sticking these things into our calculators.
Is it right?
No.
Oh, okay.
We've got fraction. Yeah.
That's fine. What's the fraction?
What's the fraction?
320. That's legit.
Over to 700. Sorry,
20,000. Sorry.
That's right. Let me have a look.
I'll say it now.
Just go answer.
Oh, you got it. It's 0.0.
Yeah.
So what was it? 2.
3.5 divided by 20,736.
Hang on. 20.
2736.
Okay. Now you see on the calculator there's an S to D button just above the on.
Yeah.
See if it's roughly the same.
Yeah, it's 0.1567. 0.01567.
There you go. So that should be. Well,
That is 'cause you
I'll let you off a rounding error, but yeah, that's fine.